Hi everyone, I'm back again. I'm here to do LeetCode problem number 70, climbing stairs. Let's read the problem. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Essentially, this problem is saying that it takes n steps to reach to the top of the staircase, and you want to figure out how many steps you have to take to reach the top. How many different ways you can reach the top if you can only take 1 or 2 steps from the base. So in this situation, there's 2 answers. You have 1 step plus another 1 step, or you could just take 2 steps and that will give you the answer of 2. And in this situation, there's 3. It takes 3 steps to reach to the top, and the answer is also 3. You could take 3 1-step operations. You could take a 1-step operation followed by a 2-step operation, as well as a 2-step operation followed by a 1-step operation. Overall, there's 3 different ways to reach to the top. So this is actually one of the most famous dynamic programming problems out there, and this is about the easiest dynamic programming problem that you will ever see. But you can do it through dynamic programming, or you could do it through iteration. And I'm going to demonstrate both methods. Let's first take a look at the constraint first, right? So the constraints are 1 is less than or equal to n, which is less than or equal to 45, which is not bad. Let's take a look at the topic. So this could be a dynamic programming, but this could also be, it says that this could also be a math, dynamic programming, or memoization problem, right? So we're going to demonstrate 2 approaches. We're going to do dynamic programming. That's the first approach. And the second approach is going to be iterative. Essentially, what we're trying to do is, one thing I do want to bring up is the Fibonacci numbers. So the Fibonacci numbers, you basically, you start with 0 and you start with 1, and you add every pair of number to get the next one. So 0 plus 1 is 1, 1 plus 1 is 2, so on and so forth, right? You could start a default, you could start at 0, or you could actually start at 1, right? So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, so on and so forth. And if we take a look at our situation, so this is 2, right? And imagine using this Fibonacci sequence, imagine this was, imagine we start the Fibonacci sequence right here, okay? We disregard this one, but imagine if we started our sequence right here, right? So if we do, then the answer is basically the ith Fibonacci number, right? So this is 2, and imagine this was the first one, this was the second one, so the answer is 2. This is the third Fibonacci number, 1, 2, 3. So this is how we're going to do it. Imagine we start the Fibonacci numbers right here, and we're just going to find the ith Fibonacci number. But in programming, everything is 0 based, so we're going to have to set the the 0th element to 1 and possibly the second element to 2, right? And so let's try doing it. Okay, so in dynamic programming, we're gonna define a results array that will host the answer. Okay, we're gonna define an array that allows us to do memoization. We're gonna treat the n equals 1 case and n equals 2 case, right? Then what we're gonna do is the following: loop from 2 to n, update the results array, and then return the rightmost element in the results array. So let's get started, right? So res equals 0 times n. If n equals 1, res 0 equals 1. L if n equals 2, res 0 equals 1, and res 1 equals 2. And then we're going to do for I in range 2 to n, we're going to do res of I equals res of I minus 1 plus res of I minus 2. And then we're going to return res I n minus 1. So I got a wrong answer. Let me take a look. Res equals 0 times n. If n equals 1, res 0 equals 1. If for I in range 2 to n, if res, let me take a look what's going on right here. Okay. This is very tricky. I forgot that if n is greater than or equal to 2, right? If n is greater than or equal to 2, then we have, if any, for n that's greater than or equal to 2, we always have to set the first and the second element. Okay, this works. Not bad, not bad. This algorithm is, the time complexity is O of n, and the space complexity is O of also n, because you have an array right here that does memoization, but it's of size n. Let's see if we can even do better than this. So that was dynamic programming. Let's see if we can do even better than this, right? So in the iterative approach, this is what we're going to do. Treat the n equals 1 case. Define first and second and set them to 1 and 2. Loop from 3 to n plus 1. Update, create, create a variable third. That's first plus second. Update first. Update second. Return second. Okay, so let's do it. If n equals 1, then you return 1. We do first equals 1 and second equals 2, right? Once again, I think this is the first Fibonacci number and this is the second Fibonacci number. This is where we choose to start our Fibonacci sequence, and we want to return the ith Fibonacci number. For I in range 3 to n plus 1, what we're going to do is third equals first plus second, first equals second, and then second equals third, and we're going to return second, okay? This is good. All right. And this is even better than the other one in that the TC is O of n, but the space SC is O of 1. We're not allocating extra space because we don't even have like an array up here to do memoization. The memoization happens with variables, right? And so we don't have to define any extra space, okay? This is one of the most famous dynamic programming problems and possibly the easiest one that you'll ever see in your life. But it's really good practice, and so for those reasons, I'm happy that I did it. I'll see you at the next one. Thank you.